This is the structural geology help video for the 3-point problem, where you're given 3 points on a topographic map, A, B, and C, and you're asked to find the strike and true dip of the bed that connects them, assuming that the bed that they're all a part of doesn't change. So it has a constant slope and it has a constant direction to it. So the difference between the one that you're going to get assigned and the ones you might see on the internet is the one that you've been assigned actually says that you're drilling down to the depths to find A, B, and C. So here A is at a depth of 10 feet, B is at a depth of 50 feet, and C is at a depth of 5 feet. So the first thing that we have to do is find the actual depths of A, B, and C. So A is on the 1,000 meter contour interval. So that means that A is actually at 990 meters. Oh, sorry, these should be meters, not feet. B is at a depth of 50 meters, so we're going to do 800 minus 50, that's 750. And C is at a depth of 5 meters, so that's 495 meters. Okay, so now we have the true depths. So the first thing you're going to do is connect A and C. You're going to connect the one that has the highest elevation with the one that has the lowest elevation. Okay, so I've connected A and C. And now we're going to find the apparent dip of the bed from A to C. So the way we're going to do this is you're going to draw yourself a little triangle and you're going to say the height difference between A and C, so the height of this triangle, is going to be the true depth of A minus the true depth of C. So that's 990 meters minus 495 meters is 495 meters. Okay, and then we've got to find the horizontal distance between the two. So I've got my scale over here. I know that every 2.5 centimeters is about 250 meters, so every centimeter is 100 meters. So that means that this is about 850 meters distance between the two. And I want to find the true dip of that, or the apparent dip, or the angle right here. Okay, so I've got the opposite side to the angle and the adjacent, so that means I use tangent. The tangent of that angle is 495 over 850. And you are going to have to use the arctan function here. Make sure your calculator is in degrees. That's what it should look like. And we get 30.214 degrees. That's your apparent dip between those two. But again, we're looking for a true dip. So then what we're going to do is we are going to, what am I going to do next? So next we need to figure out where B, if B is at an elevation of 750 meters, where would 750 meters be on this line? Okay, so to do that, let's draw another triangle. And we're going to say, well, the height difference between B and C is 750 and 495. Okay, so 750 minus 495 is 255. So we're going to say there's an elevation difference of 255 meters. I want to know what the horizontal length is, where that point's going to plot on this line. And I know already that my apparent dip is 30.2 degrees. So now I'm going to use tangent again of opposite over adjacent. So tangent of our 30.2 degrees is opposite 255 over adjacent. And with some transferring, like transfer the x over here, divide by tangent of 30.2, 255 divided by tangent of 30.2 should look like that. It gives you 438.1. So that's in meters. And that means that if we take this point from C, we need to measure out 438 meters and put a point. And that's where that elevation for B lies on the plane as it dips from A to C. So if every 100 meters is a centimeter, then I need to come out 4.38 centimeters. Just about right here. And that's where B would hit that line. So we'll call this B prime. So the line from B to B prime, I'm going to draw this in pretty dark. That is your strike. That's your strike direction, because those 2 points have the same elevation. We know that any 2 points with the same elevation define strike. Okay, so what you would do to find the direction of strike is you just come up to any point in that line and drop a 90 degree line to represent north, and measure that angle using your protractor. So, maybe you measure it and you get 30 degrees. So that would be north 30 west is your strike direction. So now we need the direction of true dip. And the way we're going to get that is we're going to actually extend B prime past this line until it makes a 90 degree angle with C. And I've pretty much done that. If you don't have compass on you to get that 90 degree angle, you can definitely use a straight piece of paper. That's fine. I'm going to use the end of my ruler to make sure I get a 90 degree angle. Okay, so there's my 90 degree angle, my triangle, and I want my true dip. Okay, so I'm going to have a third triangle. And again, I know that my height difference between this line of elevation 750 and this point of 495 was 255 meters. So this is 255 meters. And I know that the distance between these 2 points can be measured. So I'm going to measure this distance. And it looks like it's about 3.8 centimeters. So 3.8 centimeters is 380 meters. And now I need to find my true dip. So I've got opposite, I've got adjacent. I'm going to do tangent of true dip is 255 over 380. And again, you're going to use your arctan function on your calculator to find that. Okay, so look like this. Our true dip is about 33.86 degrees. Alright, now we need to think about the direction that it's dipping so that we can put our little direction on that. We know it's going to be, if we're striking northwest, we're either going to be dipping northeast or southwest. So let's think about this. A was at a higher elevation than C, so we've got to be dipping in this direction. So that means this is going to be to the northeast. Alright, so that's how to find strike and dip in a 3-point problem where your points are actually drilled and found at some kind of a depth.